Today in this video we are going to have a discussion related to sridharacharya's method, and having that concept which was provided you in the previous video, we will solve some of the questions of our exercise. And before starting the topic, I would like to recall something. First of all, we should recall quadratic equation. What the quadratic equation means? Actually, quadratic equation is a quadratic polynomials based equation. I mean to say that quadratic equation is nothing but it is corresponding equation of a quadratic polynomial. Corresponding equation of a quadratic polynomial. What may mean? Suppose that suppose that we are having a quadratic polynomial like this. Px is equal to 2x square minus 5x plus 3. This is a quadratic polynomial. As you know, for being polynomial, we need to have indices over variables, non-negative integer. So we are having that here. So it is a polynomial, and highest degree of this polynomial is 2. So why it is called quadratic polynomial? And if we want to write down px is equal to 0, then it is called corresponding equation of this polynomial. Corresponding equation of px. So mind it, never think like that these two are the same thing. No, not. If I say this stylus corresponds to me, it doesn't mean that it's mine. Maybe I'm supposed to write over the board with the help of this one only. So why it is corresponding to me? And I'm not same as this stylus is. So if we say this is a corresponding equation of this polynomial, then it does not mean that these two are the same thing. Actually, these are meant to be associated to this. So it is called quadratic equation corresponding to the polynomial px. And now, what would be the standard form of a quadratic equation? Very similar. As we know, a quadratic polynomial standard form is ax square plus bx plus c is the standard form of a quadratic polynomial where a, b, c are constants, and a, which is also known as the leading coefficient. Leading coefficient, that means coefficient of the highest degree term. So this leading coefficient should not be equal to 0. And this is the standard form of a quadratic polynomial, and therefore standard form of a quadratic equation in one variable. We took x here only. One variable will be ax square plus bx plus c is equal to 0. Clearly, as we have written here, a, b, c are constants, and the leading coefficient, that is a, the coefficient of the highest degree term, is not equal to 0. So this is the standard form of the quadratic equation. Now we want to understand some relationship or differences, you may just call in either way. So relationship between the two terms, zeros and roots. Actually, the term zero is associated to polynomial, and the term root is usually related to equation. Suppose that we are having a polynomial like this. X is equal to x square plus 5x plus 6. We can factorize to this one as this x square plus 3x plus 2x plus 6, and so x plus 3, 2 into x plus 3, taking x plus 3 as common, x plus 3 into x plus 2. If you are said to find the zeros, plural of zeros of the polynomial, then you say zeros of px are minus 3 and minus 2. That means the values of x for which the whole polynomial's value becomes 0 is called 0 of the polynomial. And now if zeros of the polynomial are minus 3 and minus 2, then if we want to say a polynomial equation, we write here, I write here, if I write polynomial equation px is equal to 0, then it means that we are writing plus 5x plus 6 is equal to 0. Clearly, with the help of this calculation, we can easily write down x plus 3 into x plus 2 is equal to 0, and therefore we say x is equal to minus 3 or x is equal to minus 2. Here, these two values are same as these two are. Here, these two are called zeros of the polynomial. Here, these two are called either solution of px is equal to 0, or you may say roots of the equation px is equal to 0. So these two are not very different, they are very alike things, When we take only the polynomial, we use to say those two values as zeros of the polynomial, and if we take the corresponding equation of the polynomial, then usually we say to that one roots of the equation or solutions of the equation. Is this clear? And that was the background before starting the use of Sridharacharya's method or completing the square method. Already you are well aware of this with the help of previous video, and now we are using some questions to make those concepts very clear. So for that purpose, I took some examples from NCRT book. This is the NCRT book, exercise 4.3, in which in the first question is said, find the roots of the following quadratic equations if they exist. That means if they exist. If they exist. If they do not exist, then we cannot find it. So if they exist, then find the exist by the method of the completing the square method, you find them. Okay, so suppose that these are existing. Later on we will feel if some unusual steps will be there, conclusion will be there, we will say that it is not possible and roots of the equation do not exist. But before begin to this one, we just assume that zeros or roots of the equation, solutions of the equations are existing. So I am taking any of the question. Suppose that I am taking the second one. Presently I am taking the second one. Okay, 2x square plus x minus 4. 2x square, I hope it was 2x square plus x minus 4 plus x minus 4 plus x minus 4 is equal to 0. Sometimes you will feel that with the help of middle term splitting method, you are unable to solve such kind of questions. Sometimes you will get both the options very clear. So at that moment, it will depend upon you to which you adopt. Okay, so primarily here we are feeling that this question cannot be solved with the help of splitting of the middle term. We are just feeling in that way, and we are going to use the completing the square method or the Sridharacharya's method to finish the solution. For that purpose, the first step, what should be taken is this. First of all, you make the coefficient of x square, that means the leading coefficient, 1. First of all, you make the leading coefficient 1. That means the coefficient of the highest degree term x square 1. For that purpose, we will divide whole the expression by 2 to the left hand side as well as to the right hand side. So divide to both the sides by 2. You have x square plus 1 by 2x minus 2 is equal to 0. This is the first step in the process of solving this one. And now the second step. Now the second step, what should be written here? Actually, with the help of only these two, x square plus 1 by 2x, we are to we are to write down a perfect square. For that purpose, we can consider this one as a square. So it will be equal to half a. And if we want to make this one a perfect square, here in place of this one, it should be 2ab. 2ab. For that, if we write here 2, okay, then obviously, we should put here b, and the product of these four must be equal to that is written here. So by feeling like that, you will find the value b. Obviously, you can write in this way. Again, I am rewriting to this one. I am rewriting to this one here. Rewriting to this one here. X square plus 1 by 2x. First of all, you feel to this one as a square, and then write plus 2ab, that is 2 into a into b. You have to write here something so that the product will be equal to 1 by 2x. 1 by 2x. So now you feel like this. 2xb must be equal to 1 by 2x. So clearly you have b is equal to 1 by 4. You can do it directly by making half the coefficient of x. And now, if it is done, what is to be written here? What is to be written here? X whole square plus 2 times x in place of b 1 by 4 plus 1 by 4 square, so that it will become a perfect square. But this term is not included. This term is not here. So we must subtract to this one. Okay. So this is the procedure, and to that procedure, we can write down directly here as this. First of all, you got here, it will become x plus 1 by 4 whole square. Mind it, this 1 by 4 is nothing but half of the coefficient of x. So you can directly write here 1 by 4, not the x, only 1 by 4, only x whole square. And then primarily you write this minus 2 because sometimes you may leave that one by mistake. So first of all, write to that one also. And as you could know here, to make the perfect square, we needed to subtract this part, because whenever we make this one, we write to this one as a whole square, then the b square 1 by 4 whole square will be there, and that is not in the previous step, so it must be subtracted. So you write here 1 by 4 and 4 square with negative sign, and now the work, the job is finished. So it is equal to minus 2 minus 1 by 16 is equal to 0. Take the numbers to the right hand side. So it will be equal to 2 plus 1 by 16, and so it will be equal to 32 plus 1, 33 by 16. And now can easily be written as x plus 1 by 4 is equal to root under 33 by 16. Mind it, we should not write only this one, you should put here plus minus sign, because we know that plus root under 33 by 16 whole square will give the same result as the minus 1. I mean, if we square the minus 2, it gives us 4, and if we square to the plus 2, also gives the 4. So whenever we want to know the square root of 4, we should put there plus minus 2. So I did it. Here, I am using the same sheet to conclude this one. So from here we can write 1x is equal to minus 1 by 4 plus minus under root 33 divided by 16 is a perfect square, so 4, and finally 4 minus 1 plus minus root under 33, and this is the solution. These are the roots. So x is equal to minus 1 plus root 33 divided by 4 is the one root, first root, and the second root x is equal to minus 1 minus root under 33 by 4. So these are the solutions or roots of the quadratic equation using the completing the square method. Again, I should take another example to make this one more clear. For that purpose, again I take an example from our book, our base book, NCERT book, and for that purpose this time I am taking this question. Question number 4. 4x square, 4x square plus 4 root 3x. 4x square plus 4 root 3x. 4 root 3x plus 3 is equal to 0. Plus 3 is equal to 0. This is another good question to understand the completing the square method for solving such kind of quadratic equations. For that purpose, primarily we need to make the coefficient of x square 1. Sometimes we do not do that one because here 4x square give an a. We can write to this one as 2x whole square, 2x whole square, 2x whole square. Okay, but I prefer to make the coefficient of x square as 1. I prefer to make coefficient of x square as 1. I am repeating. However, 4x square is a perfect square. We can proceed to use that one as a perfect square. We can proceed, but personally, I prefer to make the coefficient of x square 1. So I am making that one. So to divide both the, to make the coefficient 1, we should divide both the sides by 4. X square plus root 3x plus 3 by 4 is equal to 0. And now the half work is done. And now, as you have written in the previous question, that it becomes perfect square of x plus this one and half of the coefficient of x, is it? And later on you subtract the square of this one. Why we do that one? Again, I am repeating, x square plus 1 by 2x square. We want to make it a perfect square. For that purpose, we can write to this one, we can consider to this one as a square. But we should write here 2ab, 2ab, 2ab. So 2a into b. But what should be the value of b so that the product will be equal to half x? So we can solve that one by using this relation. If we consider 2x into b as 1 by 2x, then b must be equal to 1 by 4. So in place of b, if we put 1 by 4, then the product will be equal to 1 by 2x and it will be in the form of 2ab. So we did that one here, x square plus 2 into a and this one b. So for the complete square, there should be b square. So I have written here 1 by 4 whole square. But mind it, 1 by 4 whole square, that is 1 by 16, is not here. So we must subtract 1 by 16. That means minus 1 by 4 whole square should be there. But in the meantime, we usually miss this minus 2. So primarily you write minus 2 and then subtract to this 1 by 4 whole square. So what we did in this question, we are doing in this one. Directly I can write here x plus half of this root 3 by 2. Half of this means you divide the number by 2 whole square plus write this one because it may be left out by mistake, and finally you are expected to write down the square of this root 3 by 2 because now we are feeling that this is b, and so b square is included in the square, and in the previous step we don't have square of b such as this. In this one we are not having 1 by 16, but when we write here whole square, then this 1 by 16 1 by 4 whole square automatically is added to this one, but there is not such kind of term, so we should subtract to 1 by 4 whole square. We did in that one, so we should do here also minus of this square of this is equal to 0. So now x plus root 3 by 2 whole square plus 3 by 4 minus this is also equal to 3 by 4 is equal to 0. So clearly here these two are cancelled out. If would have not been done, हम लोग उसको दूसरी ओर ले जाते हैं, but here these two are cancelled out, so it becomes a perfect square. So x plus root 3 by 2 whole square is equal to 0. Therefore we can write x plus root 3 by 2 is equal to 0. We should not write here plus minus 0 because 0 has no sign. So we should write only 0. So clearly x is equal to minus root 3 by 2. But what you feel? You were asked to write down the zeros, not the roots, not the root. But here we are getting only one root. What is the missing term here? What is missing here? Nothing is missing. Actually, both the roots are same. As you have already read in the polynomial. Sometimes you find that there are same zeros. So for this polynomial, if we would have taken to this one a polynomial, we would have said the two zeros are same, equal to minus root 3 by 2, and having the same idea, we write here the roots of the equation. Hence the roots of the equation are minus root 3 and minus root 3. You can also to say that this equation has repeated roots. This equation has repeated roots. That is, this equation had repeated roots. That means both the roots are same. And I hope now you could understand to solve other questions, other alike questions rather I should say. And before starting to this video, you should go through to have a session with the earlier video that was associated to Sridharacharya's method. Hopefully you could understand. Thank you. Have a nice day.